All right, so continuing what we were introduced to last time with matrices, this time the focus is on multiplying matrices, which will be harder to explain. It'll take a lot more practice than what we were looking at last time. And you can get a sense of that right here by this colorful but perhaps crazy looking expression. Describes how to multiply a 2 by 3 matrix by a 3 by 2 matrix. And it looks, yeah, it's correct, and it's really shows that multiplying with matrices requires a bit of practice. For example, this matrix here, the solution will be a 2 by 2 matrix. And each of these elements here is found as the sum of 3 products. So for example, this first element, 1 in the top left corner, 1, 1. It is found by finding the product of this element times this element, plus this element times this element, plus this element times this element. And I'm adding up these 3 elements by these 3 elements. So I go across for the first and down for the next. And then I do the same thing in a different combination. So if I want to find this here, that's found by going this element times this element, and then working my way across and down, and I have the sum of these. Once I have those done, I can then move on to find all of this. It's going to be this element times this element, plus this element times this element, plus this element times this element. And finally, it leads at the last one. It's going to be this element times this element, plus this times this, plus this times this. All those added up. So clearly a lot more to explain. We really need to practice it way more than I can even just show in these notes. But let's look at a few examples. I have 3 different matrices here, A, B, and C, and I want to multiply, if possible, and we'll see it's quite often it's not possible to multiply matrices together in this order, so A times B. So let's look at A times B, which will be possible. And we'll see why others are not possible shortly. So I want to start by multiplying 1 times 5 and then working my way across in this matrix and working my way down here. So going back to the start, I have 1 times 5, which is 5, plus 0 times 2, which is 2, plus 5 times 1, which is 5, and all these are being added up to each other. Oh, sorry, 5 times, yeah. Oh, wait a minute. What am I saying? 0 times 2 is 2. Bad math teacher. That's a 0. All right, and so that's it. Those aren't 3 elements. That's a sum, 5 plus 0 plus 5, which is 10. And so the first element in my answer is actually a 10. And I'm actually halfway done here because all I want to do now is the same idea down here. Negative 2 times 5, which is negative 10. 2 times 2, which is positive 4. And then 1 times 1, which is 1. That's it. Again, those are not 3 elements. That is a sum. And I add those up, and I get negative 5. And so in the end, my matrix is just a 2 by 1 matrix. 10 over negative 5. I'll make that negative 5 a bit nicer. And for a matrix, for us to be able to multiply 2 matrices together, as we go across one way, it has to match up with how far down we're going the other. Otherwise, it's not possible, which we'll see, for example, in the next one. BA is not possible. Let me show why. If I want to multiply these together, and maybe for this one, I'll actually show it in order. So this BA, if it was possible, we would go 5 to 1 times this matrix. And so I'll write it out, but pretty quickly we'll run into a problem. So if I'm going to multiply this, I would start with 5 times 1. Okay, that's 5. But then there's nothing else beside the 5, yet there is a number below the 1. We always go this way for our first matrix and down this way, and those two have to be the same number of values there. In this case, I only have a single value here, but I have 2 values here. I just cannot multiply these, which really tells us for it to be possible for 2 matrices to multiply to one another, the first matrix, the number of columns it has to match up with the number of rows in the second. And the order we multiply matters. And so in this case, if you look in this first matrix, matrix B, it has 3 columns, but matrix A only has 2 rows. They're not the same. And so it's not possible. And that idea, that to be possible, the first matrix, the number of columns, has to match up with the number of rows of the second. Otherwise, it's not possible, which also tells us that unlike multiplication with real numbers, the order matters. A times B led us to here. B times A was not even possible. So a lot more to think about than just multiplication of real numbers. And so we'll see the same problem with BC. BC will not be possible. Because if we look at matrix B has just 1 column. That in itself is okay. But matrix C has 2 rows. Again, the number of columns of the first matrix has to match up with the number of rows of the second. And they don't, so that's not possible. All right, what about AC? We're looking at these two. Well, A has 3 columns, C has 2 rows. It's not possible. So I guess now the question is, are any of these possible? Yeah, the last one is. The last one is C times A, which I'm just going to write out down here. So CA would look like 1302 times this. And while I don't have to rewrite it, I really think it makes it a lot easier because the order matters, and it's easy to look at this the wrong way around if we don't write them out. And so this will be possible because C has 2 columns, whereas A has 2 rows. So this will always be possible. And so first I go 1 times 1, which is 1, plus 3 times 2, which is -6. So I have 1 plus -6, which is -5. Then I go, and the order doesn't exactly matter, but I'll do this way. I'll go 0 times 1, which is 1, plus 2 times -2, which is -4. And so that brings me to -4, and that goes below it. Okay, next. Now I go 1 times 0, which is 0, plus 3 times 2, which is 6. 0 plus 6 is clearly 6. Okay, my highlighting is getting really messy. I'll start circling. Next, for this term right here, I go 0 times 0, which is 0, plus 2 times 2, which is 4. So 0 plus 4 is 4. Almost done. For this term right here, or element, I should say right here, I go 1 times 5, which is 5, plus 3 times 1, which is 3. 5 plus 3 is 8. And finally, last one for what goes right here, I'm going to go for this 0 times 5, which is 0, plus 2 times 1, which is 2. 0 plus 2 is 2. So this is my matrix. Now, I will say right now, that wasn't so much difficult as it takes a lot of practice. And so until we have the practice, it feels difficult. However, even this, which is not the most complex set of matrices, multiplying by hand, even with practice, we could make a little mistake. So you do want to be aware as well how you can do this on your GDC. If possible, your GDC can do this quite quickly. And we've seen earlier in our course how we can input matrices into our GDC. And so that is something you want to learn about on your own calculator. But while we do need to understand matrix multiplication, quite often we can just do it on our GDC. But we do need to understand how to do it as well. Otherwise, we're limited by how many questions we can answer. So in this case, of the 5 different products I looked for, only 2 were possible. 3 were not possible. Because again, to be possible, the first matrix, the number of columns must match the number of rows of the second. Okay, and here's an example of a question that if we understand the order of how we multiply 2 matrices is quite quick. If we just know how to use our GDC, there's not much we can do. So I have this statement here with a bunch of variables. I want to find the value of just y. And so we've seen similar things last time. So really I want to understand how all these connect. And so for example, if I look at these 2 here, performing matrix multiplication, x squared times 1, which is x squared, plus 2y times 7, so x squared plus 2y times 7. What am I doing? I'm looking at the wrong one. X squared, oh, let's just go back to the drawing board. X squared times 1 is x squared. Then 2y times 3. I just highlighted the wrong one. 2y times 3 is 6y. And these are added to each other. But those two, again, this plus this, oh, just ignore me. This times this plus this times this must equal A. Well, I feel like I did a pretty bad job there. Let's see if I do a better job for the next. And so I have a statement. I have 3 variables there, so I can't do much there. But I also have a whole bunch of other parts I can look at. So let's look at this. Let's look at y times 1, which is y, plus 2 times 3, which is 6. And that must equal this right here, which is 4. That's more helpful. And in fact, I can now see that what y must equal. But let's just practice our multiplication more. Let's look as well at 1 times a, which is, oh, sorry. Oh, I'm ready to go home. 1 times 1, which is 1, plus x times 3, which is 3x. And I know that must equal the c right here. That's it. I may have enough to go on, but I'll just continue it, hopefully with me making less mistakes. So let's look at the next part of this. I know that x squared times 5 plus 2y times 7. So x squared times, that is 5x squared plus 14y. And that must match up with that right there, which must equal b. And then next, I know if I go y times 5 and 2 times 7. So 5y plus 14, that must equal this 4 right there. And finally, I've run out of colors to use. Let's just go back to yellow. I know if I go 1 times 5, so 5 plus 7x, that must equal 33. So these 6 statements show me the process of the matrix multiplication of going from here to here. So if I want to find A, I can do it in a number of ways. Let's start with this one right here. I know that y plus 6 equals 4, which means I know that y must equal -2. And if I know y equals -2, let's use this one right here. Oh, I need to find x as well, so let's look right here. If I look right here, 5 plus 7x equals 3. So solve for x there. I get x equals 4. And now put that here, put that there. Looks like I got a bunch of noodles on my screen. And then I get a equals x squared, which is 4 squared, plus 6 times y, 6 times -2. And then I get a equals 4. Maybe I'll get rid of all my noodles. Now, I apologize for those little goof ups I had there earlier. I will say it gets easier when you're not highlighting everything constantly, but it is also very easy to lose track of which elements you're looking at, which is why, again, a GDC is great, but we can't fully rely on it. All right, lastly, a quick applied problem, similar to something, in terms of the last lesson, looking at a couple factories. In 1 month, factory A produced 452 wallets and shipped 270 of them. Factory B produced 720 wallets and shipped 514 of them in the same amount of time. So I want to write a matrix to represent this information, where each row is going to represent one of the factories. Okay, so I have factory A and factory B. It says we want to have those in the rows, so I'm writing them on top of each other, which means as a matrix, factory A, if I look at factory A, they produced 452 wallets, I'll put that here, and they shipped 270 of them. So 452 is how many wallets they produced. 270 is how many they shipped. And maybe I'll make a little note here as well. So this is produced. This is shipped. All right, with that said, just about done this. Factory B, they produced 720 and shipped 514. So those values there. All right, so that's, now I have my matrix set up, and more importantly, I know what these values represent, which factory, what it is. And so it now tells us a bit more. It costs each factory $12.74 to produce one wallet and $2.39 to ship it. So I want to write a matrix that represents the amount of money spent by each factory on both production and shipping in 1 month. And so let me first start by writing down this matrix again. And so 452 and so on. And I'm going to label what these are again, just because it's easy to forget. So this was factory A, factory B. This was how much they produced. This was how many they shipped. So I want to show through matrix multiplication what the sum would be with these costs. And so if I look right here, this 1274, that's the cost of producing one. And so if I write that right here, then when we look at our multiplication, it would be multiplied by the 452, and it'll also be multiplied by the 720, which makes sense. That's how much each of those are. That's how much it costs to produce those. And if I put the $2.39 here for the shipping costs, notice that'll be multiplied by these. If you look at my first, if I perform the first step, I'll go 452 times $12.74 plus 270 times $2.39. However, I could also just use my GDC. Either way, whether you do it using your GDC or manually, you should get 6,403.78. And likewise, that's for factory A. So that means for factory A, they spent a total of $6,400 and change producing and shipping these wallets. And then for factory B, same idea. I could go this times this, plus this times this, or I could just use my GDC, and I get 10,401.26. The hardest part of this question, especially since you could use a GDC, was not the actual multiplication. It's understanding how I can set up these two matrices being multiplied to one another in order to actually represent something that makes sense. And as well, if I multiplied this in a different order, if I put that first, this wouldn't even be possible. All right, so long story short, matrix multiplication requires far more practice than matrix addition or subtraction. And so be patient with yourself and give yourself time with it, but also be familiar with your GDC. I'm ready to go home.